All right, guys. So this question, this worksheet is what I asked you to do during the weekends for homework. It's a little bit challenging. However, you can totally do it. Let's go over number one. And number one will be very similar to the question on the quiz that we are going to have next class. So first one, what is the actual yield? So where do we learn the actual yield? You have to start with the formula that give you the answer first, right? So our percentage yield is equal to actual yield over theoretical, right? So theoretical is the one that we find, that we calculate, right? And then the actual is the one that's given to us. Or here we have to calculate. Here, calculate from equation. Okay, so our original question, our percentage is 92.5%, right? Actual yield is X that we're looking for. And the theoretical is what we need to calculate. So if we have the theoretical, we can find our actual yield. So what we need to do is find our theoretical first, right? From the chemical reaction. So we need to write out our chemical reaction first. Our chemical reaction is aluminum hydroxide, AlOH3 plus hydrogen chloride gas plus hydrogen chloride HCl gas give you aluminum chloride AlCl3 plus water. Okay, then you have to balance the whole chemical equation. So okay, now it's balanced. 3, 1, 3, 1, 3. And also, in order to find your theoretical yield, let's just go ahead and find the molar mass of each compound. Ta-da! We find the molar mass of aluminum hydroxide and aluminum chloride. Reason why I'm only use these two is because in the question it says 15.6 gram of aluminum hydroxide. So that's our starting material. It reacts with excess hydrogen chloride gas. So hydrogen chloride is excess. So in order to find our aluminum chloride, we need to use aluminum hydroxide. We need to use this. So same thing, we have to convert the actual gram, 15.6 into mole first. 15.6 gram AlOH3. So 1 mole AlOH3 is 78 grams. So that way we convert gram to mole of aluminum hydroxide. However, we have to keep going because we're looking for the actual theoretical yield of aluminum chloride in grams. So the mole ratio, step 2, find the mole ratio. Mole ratio of aluminum hydroxide to aluminum chloride is 1 to 1. So 1 mole, 1 mole. Of, I don't know why it's doing this. AlOH3 give you 1 mole of AlCl3. All right, so we convert the mole of aluminum hydroxide to mole of aluminum chloride. Now we have to convert back AlCl to gram, which is 133 gram AlCl3. So you multiply the top, divide by the bottom. 15.6 times 133 divided by 78 is 26.6. 26.6 gram of Al aluminum chloride. Then, once we find this theoretical yield, we can plug this number back into our equation. So 92.5% is equal x over 26.6 gram. So you cross multiply 26.6 gram times 0.925 equal to 24.6 gram aluminum chloride. And that's your answer. Okay? Number 2, dividing the number of mole of one reactant by the number of mole of the other reactant is called the what ratio? So it's called, it should be D, because we all know it's a mole ratio, but there's no answer choices, so none of the above. All right, verify the sequence. For steps, for calculation, the theoretical yield of a substance. Okay, first one is always balance equation. Okay, and then convert the given amount to mole, that's correct, and then convert the mole of limiting reagent to mass of the desired product to find the theoretical yield, that's correct, and dividing each amount by the coefficient from balance equation, no, that's not right. So your answer is false. Okay, next one. 12 gram of aluminum sulfate react with the 6 gram of sodium hydroxide. The limiting reagent will be aluminum sulfate. Let's take a look, right? So remember, in order to find limiting reagent first of all, we have to write the coefficient. Ooh, why is it keep doing the yeah? Ooh. Okay, find the coefficient, right? So our coefficient of aluminum sulfate is 1, react with 6 sodium hydroxide. So remember the 3 steps we do to find limiting reagent? Number 1 is to convert all the grams to moles, right? So aluminum sulfate, its molar mass is 342 gram per mole. And then sodium hydroxide is 40 gram per mole. And we set up both equation, 12 gram of AlSO4 3 convert back to mole. 1 mole is 342 gram. It gives you 120 or 12 divided by 342 is 0.035 mole of AlSO4. And then you convert the gram of gram of sodium hydroxide. So 1 mole of sodium hydroxide is 40 gram. Do the calculation. 6 divided by 40 is 0.15 mole of NaOH. Right? Okay, where do you know? 1 AlSO4 sodium aluminum sulfate react with 6 sodium hydroxide. And if we compare this number to this number, 0.035 times 6 is 0.21 mole of NaOH. So if we use this amount of aluminum sulfate, we need 0.21 mole of sodium hydroxide, but we only have 0.15. So this is limiting. So it says the limiting reagent is aluminum sulfate, which is false. The limiting reagent is sodium hydroxide. Okay. Question number 5. All right, question number 5. Here you have a balance equation. 3, 8, 1, and 6. And instead, in the question, instead of giving you the gram of each reactant, right? CO2 and ammonia, it gives you the mole. So where they have the mole, we don't have to do the first step of finding limiting reagent anymore. All we have to do is compare these two mole. So 3 to 8, right? What you have, the ratio 1.2 of chlorine and then 2.4 is more like 1 to 2. So which one is limiting? Let's see. 3Cl2 over 8NH3. If we assume the first mole is limiting over x, you cross multiply 3x equal 9.6 and x equal 3.2 mole of NH3. So if you used up 1.2 of chlorine, you need 3.2 mole of ammonia, yet we have 2.4 mole of ammonia. So what we have is less than what we need. So NH3 is limiting. Okay, the question asks us the percent yield, and then the question also gives us the actual yield, right? So we need to find the theoretical yield from limiting reagent. So limiting is 2.4 mole of NH3, and that gives us, based on the mole ratio, 8 NH3 give us 1 and 2. That's in mole, okay? Then 1 mole of N2 is 14 gram. So you calculate it, 2.4 times 14 divided by 8 is 4.2 gram in 2. So this is your theoretical yield, right? My bad. 14 is 1N. So 2N is 28. So answer will be 8.4 grams. So that's your actual, that's your theoretical. So percentage yield is equal to actual over theoretical. Actual is 6.3 gram over 8.2 gram times 100%, right? So it's 6.3 divided by 8.2. Your answer is 77% C. Number 6, a balanced equation and the amount of starting material are required to calculate the theoretical yield. Okay, so we have number 7, number 8, number 9, and number 10 is false. So number 7, 8, 9, I will show you the answer in the PDF form of this practice key. So I'm only going to give you the answer. I want you to practice on your own to get the answer by yourself. And the next class, we're going to have a quiz on these.